Hello friends, welcome back to my YouTube channel Chemistry Basics. Today we are going to see a very important chapter, Aldehydes and Ketones. In this chapter, we will discuss about introduction and nomenclature of aldehydes and ketones. And in next part, we will see preparations and reactions. If you are visiting this channel first time, so please subscribe the channel and press the bell icon button so you'll get the notification of the next video. And if you like it, please share this video. What is meant by aldehydes and ketones? So aldehydes and ketones are the carbonyl compounds, or collectively they are known as a carbonyl compounds, as they have C double bond O group. This is the carbonyl group. So here this is the aldehyde and is ketone. So in aldehyde, this R group, it may be hydrogen, or it may be alkyl, or it may be aryl group. When you have a R is equal to hydrogen, then it will be a formaldehyde. If you have any alkyl group here, then it becomes a aldehyde, and obviously aliphatic aldehyde. And if you have a aryl group here, then it will be a aromatic aldehyde. So hydrogen, formaldehyde, alkyl group, aliphatic aldehydes, and if you have a aryl group, it will be a aromatic aldehyde. For example, if you are taking here methyl group, so the name of compound is acetaldehyde. If you have a ketones, so the R and R dash both are either alkyl or aryl group. See, R or R dash both should be alkyl or aryl group. If R and R dash both are alkyl groups, then what will happen? That will be the aliphatic ketone. And if you have any one of these or both aryl groups, any one, if this is a aryl group or both are the aryl group, definitely that will be the aromatic ketone. Example of this I have taken here, only one example I have taken, both are alkyl group, that methyl, then name of that compound will be the acetone. Now we'll go for the nomenclature. So we'll study the nomenclature differently. First we'll see the aldehydes and then we'll see for the ketones. So first method by which we have to give the names, it's a common name system. It is also called as a trivial name system, common name system or trivial name system. So how that aldehydes are named? So for that you should know which carboxylic acid is formed after that corresponding aldehyde. So see, aldehydes are named according to their name of corresponding acids formed after oxidation of them. Suffix IC acid is replaced by aldehyde word. See, this is the one aldehyde. If it will undergo oxidation, so simple, we are adding a oxygen here. So what you will get? CH3COOH. So see here, you are getting this. So this is the acid you are getting. Now name of this acid is acetic acid. Now how to give the name to aldehyde? Simple. This IC acid is replaced by aldehyde word. This prefix ACET remains as it is. Only IC acid is replaced by aldehyde. So for that you should know which acid or which carboxylic acid is formed after the oxidation of that aldehyde. Okay. Now IUPAC nomenclature. All of you know that IUPAC means what? So it is the International Union of Pure and Applied Chemistry. Always remember that, International Union of Pure and Applied Chemistry. Now, what's the steps here during this nomenclature system? So first thing, select the longest parent chain containing aldehyde group. Then derive the name from the parent alkane by replacing E of alkane by suffix Al. I'll repeat second step. Derive the name from the parent alkane by replacing E of alkane by suffix al. So you have to just replace this E by al. So see here, an example. Suppose this is the example HCHO. How many carbons are present here? Only one. So as only one carbon present, its parent name is methane. One carbon, parent alkane name, obviously parent alkane name. And then what will be the aldehyde name? So simple, I am taking this methane as it is, and just this E is replaced by Al. So name of this aldehyde becomes methanol. Methanol. Okay. So E is replaced by Al. What's the important note when you are giving this IUPAC nomenclature? If you have a branched aldehyde or long chain aldehyde, then carbon atom of aldehyde group always assigned as number 1. So when you are giving the numbering, aldehydic carbonyl group should be assigned as the number 1. Okay. So let's see some examples that will make you more clear. This is the structure. First structure HCHO. It's common and trivial name. It's a formaldehyde as its oxidation gives you formic acid, and therefore its common or trivial name is formaldehyde. An IUPAC name, only one carbon, therefore methane, and E is replaced by Al, therefore it's methanol. Now second, CH3CHO, number of carbons are 2. Okay. Now common name of this particular compound is acetaldehyde, because from this you will get the acetic acid. Okay. And now we have to give the IUPAC name. So see 1, 2, and therefore it's ethane, E replaced by Al, you'll get the ethanol. Next, CH3CH2CHO, propionaldehyde. That's the common name. And IUPAC name, propanol. Everywhere if you see, just E is replaced by Al. If you have a substituted aldehydes, see aldehydic carbon always have number 1. 1, 2, 3, it's longest parent chain. So definitely it is a propionaldehyde. And in common name system, if you have a branched there, then it is denoted by alpha. So alpha comes in commons. And therefore, how I can give the name? Alpha methyl propionaldehyde. And when you have a IUPAC nomenclature, it involves numbering 1, 2, 3. And at the second number, you will have a methyl group. Therefore, name is 2-methyl propanol. 2-methyl propanol. Okay, so we have taken some examples. I think you'll get the idea about this, how to give the names. Still some other examples are there of the aromatic aldehydes now. Aromatic aldehydes. The simplest aromatic aldehyde is benzaldehyde. So this is the parent in the aromatic aldehyde. Simple. So benzene ring is attached to aldehyde group. So this is known as a benzaldehyde. And other aromatic aldehydes are derived from benzaldehyde. So this is the benzaldehyde, and in this compound at ortho position you will have a methyl group. So as at ortho position you will have a methyl group, so we can give the name orthomethyl benzaldehyde. So here it is, orthomethyl benzaldehyde here. Okay. If you want to give the IUPAC nomenclature, then 1, 2 at the second position you will have a methyl group, and therefore it is known as a 2-methyl. This is the benzaldehyde parent. So 2-methyl benzaldehyde. One more common name is there, orthotolulaldehyde. Orthotolulaldehyde. Okay. So at least you should know the IUPAC nomenclature, 2-methyl benzaldehyde. Now here again, just at the second position you will have a hydroxyl group, and therefore name will be 2-hydroxybenzaldehyde. Another name, that's the ortho-meta-para system. So at the ortho position, you will have a hydroxyl group, so ortho-hydroxybenzaldehyde. And one more familiar name to this, it is salicylaldehyde. Salicylaldehyde. Okay. Still we have some other aldehydic compounds. So aromatic compounds which having aldehyde group in side chain. So phenyl group considered as now substituent in this case. So suppose you have this 1, 2. So at the carbon number second, you will have a phenyl substituent, and therefore I can give the name to this, or we can give the name to this 2-phenyl ethanol, because 2 carbon chain is there, 1, 2. So ethanol, and at the second position phenyl group is there, so 2-phenyl ethanol. If you want to give the common name, so it becomes a alpha carbon, and therefore it is a alpha phenyl acetaldehyde. One more compound, so in this also, that aldehyde group is present in the side chain. So as it is present in the side chain, again phenyl ring is considered as a substituent. Okay, so 1, 2, 3. So now here aldehyde group is present at the carbon number second, double bond is start, that is the in, and at third position phenyl is there. So therefore 3-phenyl. As 3 carbons are in the parent chain, it's a propane derivative, so I have written here prop. At the second position double bond starts, so therefore 2 in, and as it is a aldehyde, it is ended by suffix al. So see the name 3-phenyl prop 2-enol. So in this way you can give the name to such a type of substituted or the compounds in which aldehyde group is in side chain. Well familiar name for this compound is a cinnamaldehyde. Cinnamaldehyde. Okay. So we have taken the nomenclature of aldehydes. Now we'll go for nomenclature of ketones. Nomenclature of ketones. So in this we'll see first common name system. So it is the simplest. Ketones are named by using name of alkyl groups attached to the carbonyl group. So whatever alkyl groups attached to carbonyl group, so you have to just write their names followed by ketone word. Okay. Let's see the example. So it is the methyl groups present here which are attached to the carbonyl. So as 2 methyl groups attached, so I have written here dimethyl ketone. So the dimethyl ketone, and it's a well familiar name or market name is acetone. One more compound I have taken here. So to this side methyl group is a alkyl group, and to this side ethyl, and it's a ketone. So in ethyl and methyl, alphabetically ethyl group comes first, and therefore we have given the name ethyl methyl ketone. It is abbreviated as EMK. So first letters of these words. Okay, so EMK, and therefore we can call it EMK also. Okay, so this is about the common name system of ketones. IUPAC nomenclature. So as usual, first step, select the longest parent chain containing carbonyl group. Then derive the name from parent alkane by replacing E of alkane by suffix ONE. So if you see here, this alkane, that E is replaced by ONE. It becomes a alkanone. Let's take the example. CH3CO, CH3. So it's acetone actually. So how many number of carbons? 3. So definitely its parent alkane name will be propane. So here 1, 2, 3. Okay. What will be the ketone name? Here has to be a ketone. It's not aldehyde. It's a ketone name. So its ketone name is what? Propanone. E is replaced by ON. What is the important note during this nomenclature of the ketones? Numbering should be in such a way that in which carbon atom of carbonyl always assigned as lowest number in chain. Always lowest number in chain. Okay. So these are some examples of ketones. So here 1, 2, 3. 3 carbons present. So propane derivative. So E is replaced by ONE and therefore it is known as a propanone. Now here 1, 2 and here still 2 carbons are there. So total number of carbons are 4 and therefore it's a butane derivative. As it is a butane derivative, E is replaced by ONE, but at the carbon number second that ketonic group present and therefore it's a butane 2-one. Now third number or third structure, see here 1, 2, 3, 4, 5. So definitely pentane derivative at the carbon number second, carbonyl group present and therefore it becomes 2-one. Let's take some longer or larger compound there. So 7 carbons are present there. So definitely it's heptane. And at the carbon number 4, ketonic group present and therefore it becomes a heptane 4-one. Suppose you have a cyclic ketones. This is a cyclic ketone. So as it is a cyclic, so prefix should be cyclo. 6 carbons are there and therefore it is a hexane and E is replaced by ONE. That's it. So cyclohexanone. Cyclo is very important cyclic compound. So, okay. Now one more substituted cyclohexane at the carbon number second. You will have a methyl group and therefore we can write 2-methyl cyclohexanone. One more compound. It's now substituent present at this position. So numbering should be in that way. Carbonyl carbon should have the lowest number and substituent also come earlier. So first, second, third. So don't go like this 1, 2, 3, 4, 5. So if you are going by this way, the substituent will be at the 5th position and that will be not the correct numbering. So you have to go by this way. So you have to decide which will be the correct numbering. Okay. So 1, 2, 3. So at the carbon number third, you will have a methyl group and therefore it becomes a 3-methyl cyclohexanone. That's one compound again. So also a cyclic compound and here double bond is also present. That's the alkene and substituent is also present. Okay. So numbering should be in that way where carbonyl group always have the number 1. So 1, 2, 3. So at the carbon number third, you will have a methyl group. Therefore, I have written here 3-methyl. Then cyclopent. Why cyclopent? 5 carbons in the ring and it's a cyclic one. So cyclopent and at the carbon number second, double bond starts. So therefore, it's in and it's always ended by ONE as it is ketonic group. So 3-methyl cyclopent 2-enone. Okay, 2-enone. So these are some examples that will make you more clear how to give the names to ketones. Suppose you have aldehyde and ketonic functional group in one and the same molecule. So ketonic group is present as well as aldehyde group is present. Then which will be considered as a principal? So aldehyde should be considered as a principal functional group. So give the number 1 to aldehyde and then second, third, fourth, fifth, sixth, seventh. So that sequence will be there. Okay. So at the carbon number 6, you will have a substituent methyl. At the carbon number 4, you will have a ketonic group. Ketonic group is also known as a oxo group when you are giving the IUPAC nomenclature. Okay. And as 7 carbons are there, it's a heptane derivative and E is replaced by Al and therefore the name becomes 6-methyl 4-oxoheptanol. Okay, so in this way we can give the names to the compounds which contains both aldehydes and ketonic functional groups. Okay. Now still we are in nomenclature of the aromatic ketones. The aromatic ketones are usually known by their common names. Common names, simple. Here it is. Suppose we have this particular aromatic ketone. So it is known as a, by common name, it's a methyl, it's a phenyl substituent followed by ketone. M comes earlier alphabetically and therefore it becomes a methyl phenyl ketone. It has another one market name or well familiar with a name acetophenone. Okay. Next one, here is the ethyl group, here is the phenyl group. So ethyl phenyl ketone and its common name is the propiophenone also. And lastly, we have taken it two phenyl rings attached to the carbonyl. So as two phenyl rings, it becomes diphenyl ketone and its other name or market name is benzophenone. Okay. So in this way, you can give the names to the aldehydes. And so thank you very much for watching this video. Please subscribe my channel Chemistry Basics and press the bell icon button so you'll get the notification of the next video. And if you like this video, please share and comment in the comment box. Thank you very much.